going to finish 2-4 though. Just going to start it.
I think you should start it.
I'm starting it.
I'm gonna get a piece of paper out and I'll give them.
There's not much more to talk about, but this book separates it into more on slope.
You don't have to teach anything in books.
Oh yeah, this is really important stuff. Lines are important. This stuff is also important. This deals with parallel and perpendicular. I used to teach the proofs of why these things are true, and I found them to be tedious and long, and most people forgot their geometry facts. You know, similar triangles, congruent triangles, all that fun stuff. So, when we're talking about parallel lines, what are we really talking about? Not coordinate plane-wise, but just plane-wise, like old geometry.
They never cross each other.
The two lines in a plane that never ever intersect. What's important is they're in a plane, because if I have two lines in space, I can draw them any which way, and I could have two lines not intersect. So once they're in the plane, they don't intersect. So two lines in a plane that never ever intersect. Generally drawn this way. How do I know they never intersect?
Because they have the same thing. The slope is like.
Can you prove it?
Yeah.
Yes.
Really? You can prove two lines are parallel.
I
I can't.
cannot. I know you can.
Well, I don't know why. Because it's an assumed truth. You have to have something that's assumed in math, like 1 + 1 is equal to 2. You have to believe that it's true for the rest of math to work. Well, two lines being parallel, you can't prove it's true because the lines go off forever in both directions. So how do I know they don't intersect someplace way out there or way back there? So we just take it for granted that we can define these two lines are parallel and they never ever intersect. There are geometries where two parallel lines do intersect.
We don't want to know.
Oh, you actually do know one of them. If you look at longitudes on the Earth, they come from the North Pole and they come down to the equator. How do they hit the equator?
They intersect.
At right angles. So you have these two lines that are intersecting a common line at perpendicular angles. Therefore, those two lines are parallel by the definitions that we do in Euclidean geometry. So it's kind of an idea that those parallel lines actually intersect. Yeah, geometry is wonderful.
I had that.
The other one is perpendicular. What's perpendicular?
When they do intersect.
Well, yeah, they do intersect, but all lines intersect except for parallel lines. So what's special about perpendicular?
They have the same, or the opposite slope.
They form a right angle. So if you have two lines that are perpendicular to one another, they have to intersect in such a way that this is a right angle.
But doesn't this have the slope? Can you define it by slope?
I haven't talked about slope yet. I'm just talking about geometry. I'm not even talking
That's
about
what
x's and y's yet. Okay, so now let's talk about x's and y's. If this is line 1 and this is line 2, line 1 has a slope of m1, line 2 has a slope of m2. Notice I'm not using change in y over change in x here. When I write m1 and m2, I know their values. When I write delta y over delta x, sometimes I don't. If two lines are parallel, we can say this. Line 1 is parallel to line 2. Anybody know what IFF is?
If and only E.
Awesome. Where'd you learn that?
Miss News.
Awesome. If and only if. So line 1 is parallel to line 2 if and only if m1 is equal to m2. They have to have the exact same slope. In other words, their rises over runs are exactly the same. What?
Translate that, Scribble.
Line 1 is parallel, that's the symbol for parallel, to line 2. This means if and only if. I'll describe that in a second. M1 as a number is equal to M2 another number. Their slopes are equal. Now, if and only if is a cool thing. It actually is two sentences in one.
Parallel means that the lines are the slope is equal.
This is two sentences. It says, if the lines are parallel, then their slopes are equal. But it also reads, if the slopes are equal, then the lines are parallel. You can read the sentence in both directions. If-then statements, you have to go left to right. If and only if statements, you can go both ways. You can go both ways. So that's a cool thing to say. Where do most people make their mistake? This one. Why? Because if I give you a slope and I ask you for a parallel slope, do I want you to do anything?
No, because
Nope.
the slope is the same.
They're exactly the same, but a lot of people think that, oh, there has to be something, this is a trick question, you have to do something to it. But if I ask for a parallel, don't change a thing. Just leave it alone. If I tell you the slope is 2, the slope is 2 for parallel lines. Perpendicular is a little trickier. If this is line 1 and he has a slope of m1, and this is line 2 and he has a slope of m2, and these are provable. It's just I don't want to go through the proof. They take about 20 minutes each. Well, 20 minutes for this one especially. The theorem, or the way you define it, becomes this way. Line 1 is perpendicular to line 2 if and only if the product of the slopes is equal to -1. Now let me ask you a silly question. If I said the product of two numbers is equal to 1, what do you know about the two numbers?
Is opposite is 1.
I know, the product of them is 1. They both could be 1. That's boring and trivial. But what if one of them was 2? What would the other number have to be? 1 over 2. And if the number was 2/3, then the other number has to be?
3 over 2.
3 over 2. What are those two things called?
Opposite.
They're not called opposites. Reciprocal is one word for it, but if we go back to properties, what are they called?
Yeah, we off of them.
No, we're not. I told you, never off of them.
I didn't.
Multiplicative
Inverse.
inverses.
Inverse.
A multiplicative inverse. Now, this is really close to a multiplicative inverse, except it's not equal to +1, it's equal to -1. That means if one number is positive, the other one has to be negative. So over here in parallel land, if I tell you that m1 is equal to 2/3, then m2 has to equal 2/3. Over here in perpendicular land, if I tell you that m1 is equal to 2/3, m2 is equal to -3/2. It has a fancy name. It's called negative reciprocal. Negative reciprocal. Opposite.
Like if you, I just
Opposite reciprocal. Yeah, I guess that would work.
Because
But
you know, if
take
it's
its
positive,
opposite.
it's negative, and then you yeah.
I've always called it negative reciprocal. But that's
I learned opposite.
I like opposite.
So that's
kind of cool.
that's multiplicative identity or
But it's
inverse.
not always a
multiplicative
negative.
inverse.
That's just what they are.
Right.
The better way to remember it is opposite reciprocal or negative reciprocal. Either one.
But it's not always a negative percent.
Always. Perpendicular is always a negative reciprocal. It has to be. Because the product of these two numbers.
Already negative.
Okay. If I give you that m1 is equal to -3, then m2 has to equal 1/3.
Oh, opposite reciprocal.
Okay. So why you? So
You have to flip it and change its sign.
It's just, you take the opposite and the reciprocal of it.
You have to flip it and change its sign.
That's why I said opposite.
I
Because
don't
no.
like. I
A
don't
lot of
like
people think
negative.
opposite is that motion.
Yeah.
Yeah. Which is bad, but that's alright.
That's what the reciprocal for.
Now we can do fun things like this.
Can we just continue without our desk?
Yeah. For example, find the equation of the line that is perpendicular
Oh man, I'm gonna regret this.
2x minus 3y is equal to 9 and goes through goes through -6, 3. Find the equation of the line that is perpendicular to 2x minus 3y is equal to 9 and goes through the point -6, 3. I tried to make this one as nice as possible.
And you made this one up too?
But I made it as nice as possible, you'll see.
Okay.
Alright, before I even start, we're trying to find the equation of a line. That tells us an invisible direction of you need
The slope?
a slope and a point. I have
Yeah,
a point, so I need a slope. The slope is going to come from what though?
The equation.
That equation. So I'm going to take 2x minus 3y and set it equal to 9 and do what with it? How do you find the slope?
Yeah, walk by itself.
Put it in the slope intercept.
Put it in slope and intercept form, solve for y. So if I solve for y, I get -3y is equal to -2x plus 9. Yes, you should be able to do these quickly. Divide by -3 and you get y equals positive 2/3 x minus 3. I could care less about the -3 unless I ask you to graph it, which I sometimes do.
So the slope is 2/3 x.
So the slope
Negative 3x.
is 2/3. Not 2/3 x. It's
Okay.
2/3. It's a coefficient. I don't care about the y-intercept, but what do I want out of this? Well, I want the perpendicular slope. Highly suggest you write it this way so you see what you're getting out of it.
-3/2.
-3/2. So now I have a slope. I need to use this one. Oh, by the way, if it was parallel,
It'd be the
just
same.
leave it alone. It's 2/3. But this is perpendicular. So then we do y minus y sub 1 equals m times x minus x sub 1. And we plug in what we know. What's y1?
Gosh, wait a minute. Y minus Y1 is what?
Y minus 3.
It's M.
And m is
Negative
-3 halves. X minus, which makes it
+6.
+6. Now here I highly suggest you don't multiply by 2 to get rid of the fractions because 2 goes into 6. I set it up nice. So you get y minus 3 is equal to -2, 2, 3. Ah, dang it. Y minus 3 is equal to -3 halves x minus 9. 2 goes into 6, 3. 3 times 3 is 9, minus 9. And then finally, y minus, or not y minus, add 3 to both sides. -3 halves x. What?
I mean, minus
It's
Plus
negative-
12. Where'd you get plus?
-6.
-6. I know what you did. You
Yeah.
went negative times a negative is yeah, no, don't do that. So here's my equation of the line that is perpendicular to this one way up here. Now what's really cool is if you graph both of them, and they actually do run into each other at right angles. So for homework, graph both of those.
Do what?
Graph both of those. Graph the original line. This one, y equals 2/3 x minus 3. And also graph y equals -3 halves x minus 6. And see if they run into each other at right angles. They should. Unless you graphed them wrong. If your lines end up looking like this, you did something wrong. Because obviously those two lines are not perpendicular. They have to look like they're perpendicular. It's a good test to see if you know how to graph. 2-2 actually.
2-2.
Yeah, but before we get there, we have to finish 2-4. There's a little piece in 2-2 that I kind of left off because it didn't really fit where it was, and I want to show you where it really does fit.
All right, here we go.
So if we finish 2-4, it starts off with a nice little pretty picture of a graph. Any random graph will do. So let's say our graph is doing, this. And we'll call this thing f of x. Awesome. And we're going to look at two values. One of them down here is a. The other one over here, let's call it b. So we have a specific... I think the batteries in this are dying.
You said that last.
I know, I forgot to change them. There, that worked. And if we go up to the graph, and we plot this point, what is the coordinate of that point?
6.
No making up points. It's a very specific coordinate.
1.
We know what the x-coordinate is,
A.
A. So therefore the y-coordinate is? How would you find the y-coordinate if
0.
I know x is equal to a?
Put 0 in for
A.
F. I mean, X is A.
X is equal to a, so what's y equal to?
Just whatever it is.
No, it's very specific.
F
F of a.
Sweet.
You take a and you plug it into the function. And that gives you your y-coordinate, just like if it was a number and I gave you f of x equals 2x. You take x, you plug it in, and you get y. So this is saying I have x is equal to a. If I plug it into the f function, I'm going to get my y. Okay. Over here, we go up to the graph, we have this coordinate here, and it's going to be b, comma,
F of B.
f of b. So I have these 2 points on a graph. And between these 2 points is this line. And we can find the slope of this line. Okay. Now let me explain what this is. This is called a secant. if you went back into geometry and you talked about all the different names of the lines around a circle, one of them happens to be called a secant. It's a line that hits a circle twice. Okay, so what the heck does this mean? Well, if this is time down here on the x-axis and this is distance on the y-axis, this is how far away you are from home at A hours. This is how far away from home you are at B hours. So the slope of this line would be your velocity, how fast you're going, average velocity. For instance, if you drove to school today, your car was not constantly doing 70 miles per hour. It first had to go slow in the little neighborhoods. You get on the highway, you get up to 75, 80.
Neighborhoods?
Little neighborhoods, like, you know, where I live, you can only do 30. So you have to get out of there first, and you have stop signs and you're pausing. But if you choose your time to be, you know, 0, and how long it took you to get here to be, well, let's say 1 hour, and it took you, not 1 hour, how long does it take you?
20 minutes.
Yeah, let's make it 1 hour. It makes it easier. And school was 100 miles away now, 50 miles away. That would mean you were doing 50 miles per hour, but you weren't doing that all the time. So this line represents what's called the average value, average rate of speed, average velocity, if you want to call it that. So we're going to call this secant line, the slope of it, the average value of f of x on the interval from a to b, on this little interval ab, where a could be anything and b could be anything, but they're fixed values. They're fixed values. So if I set this up, it's a slope, so change in y over change in x. What's my change in y?
My change in y will be f of b minus f of a.
Which would follow the book, over the change in x, which is,
b minus a.
and there you go. So if you see these words called average value, the thing you want to change it over to is change in y over change in x. If they're saying the average value of a function, you're looking for slope. When you're looking for slope, all you need is 2 coordinates on the graph. So you're going to find these 2 points, find their slope, and there's your average value. For example, you can change markers. If I find the average value of f of x on -2 to 1 for f of x is equal to 4 minus 2x minus x squared. Some ugly function. What do I need to do? What the heck does that little bracket -2 comma +1 mean? Well, they mean include, but what is it talking about? What kind of values? There's only 2 types of values.
X and y?
X and y, so which one is it?
Is the x?
It's the x, because usually we only talk about x. The only time we talk about y is talking about range. So when I say bracket -2 comma 1, it's telling me 2 things, that x is equal to -2 and x is equal to +1. Now the second part comes up. If I tell you what x is equal to, you need to tell me what y is equal to. Is that golden rule for most of this chapter. So if x is equal to -2, how do you find y? Plug it in. So you're going to go f of -2 is equal to 4 minus 2 times -2 minus -2 all squared. Awesome. So f of -2 is equal to 4 plus 4 minus 4, which is equal to 4. 4. A lot of 4s there. So f of -2 is equal to +4. This is a coordinate, -2 comma 4. It's that beauty of function notation. You just take the point, pull it right out. All right, and we also need to find the easier of the two, f of 1. So it's 4 minus 2 times 1 minus 1 all squared. All right, so f of 1 is equal to 4 minus 2 minus 1. Which one?
1.
It equals 1. So f of 1 is equal to 1. That gives me another coordinate, 1 comma 1. So after you do that, we need to find the slope, change in y over change in x, which is the same thing as the average value of the function on this interval from -2 to 1. So what's my change in y? 4 minus 1, change in x? -2 minus 1, which is equal to, oh, this is a nice one. 3 over, which has the average rate of change of -1. The average rate of change of this function on this interval is down 1 over 1. Down 1 over 1. That's it. That's all they're looking for.
That's what I did on the quiz. I didn't plot the 0, 4. I just did up or down 1 over 1, down 1 over 1, because I just did slope.
You started from 0, 0 then.
Yeah.
That's why you have to have a point first, and then the slope.
I always forget the point.
All right, let's go back to this picture. What?
So what is this? What is this showing? Is this negative? So this -1 is the slope of the secant?
Yes. It is called the average rate of change of the function between those 2 points.
Okay.
That happen to be on the function. It's you won't understand it until it becomes applicable. Like if I gave you this f of x is the profit of making widgets, x widgets.
Okay, I got you.
Then the rate of change of making -2 widgets to making 1 widgets would be you're losing a profit of $1 per widget on average. But in this case, it really doesn't make any sense because I chose -2.
Right. Yeah.
Don't make 2 widgets. Same picture, different flavor. And this one's going to take the rest of class because it's really important if you ever go on. And I always assume that you are going on in math, and I don't care if you say you're not. I
This is
assume
my
that you
last
are.
math. This
me
is my
too.
last math.
I scared you that much. Huh?
No, this is all I need for my degree.
I'm thinking taking calculus just for fun.
Look,
That's what.
something wrong with you too. Is it still 2-4 or?
This goes back to 2-2, but this is related to what we just did.
Okay.
And it's extremely important if you go into calculus. Difference quotient. The book just throws the formula at you. I want to show you where it comes from. Just for the fun of it. It starts off with the same type of picture, just some graph. And we're going to call this graph, let's call it g of x this time. G of x. And unlike the average rate of change, I'm going to pick any value. Where a and b were very fixed, they stayed in one position on the graph, I'm going to choose a value on the x-axis that can represent all of the x values. And the easiest way to do that is to start with x. So x can be anywhere on this x-axis. It can float to the left, it can float to the right. And we're going to go up to the graph and plot its its associated point. And what is the coordinate of this associated point for x? X comma g of x. So once I pick an x value, I plug it into the g function, and that gives me my y coordinate. Instead of picking another value over here that's fixed, I want to pick another one that can be manipulated. I can move it any which way that I want. So what I'm going to do is I'm going to push away from x a distance of h. Now h could be positive or it could be negative. Now if it's positive, it's going to move the point to the right. If it's negative, it's obviously going to move the point to the left. Most textbooks push it to the right.
You get to choose?
Yeah, h can be anything. The only thing h cannot be is 0. It can't be 0 for a reason when we get to it. So if I push it h units to the right, over here, what would the coordinate of that one be? If this one is x, this one would have to be
H plus the x.
and switch it around and we'll have it right.
X.
Most people write it x plus h. If you write h plus x, it won't screw up anything. It'll just look fun. Now, if you go up to the graph here, you get another point. And the coordinate of this point is
X plus H.
x plus h, comma, g of
Wait, H, X.
G of X plus H?
g of x plus h. You have to plug the whole thing in. You can't plug in parts of it. You have to plug in the entire coordinate. So the x coordinate is x plus h, so the y coordinate has to be g of x plus h. If I called this y plus z plus 2, you'd have to plug in g of y plus z plus 2, whatever it is. Again, we have this line going through these two, and again, it's called the secant line. And again, we want to find the slope of the secant line. Okay. So the slope of the secant line, change in y over change in x, is equal to, what's the change in y? Pick the ugly one first.
X plus H.
Ah.
That's X.
It's
You
gonna be
change
G of-
in y.
It's gonna
G
be
of X plus
G of
H.
H.
G of x plus h
X plus H.
minus
Minus
X.
G of X.
g of x, don't forget the
Okay.
g, you
I
need
still
that.
don't have the X.
I noticed.
Over
Over
X plus H.
x plus h
Minus X.
minus x. Now, with the average rate of change function or formula, it's f of b minus f of a over b minus a. You have two things in the top and two things in the bottom. The nice thing about this formula is what happens to the x's.
They cancel out.
They cancel out, and you get this little thing. G of x plus h minus g of x, it all over h. This is called the difference quotient. Difference quotient. And what's nice about it is you get to choose whatever h is, as long as it's not equal to
0.
because you can't divide by
0.
0. Now here's the beautiful thing. We can get h as close to 0 as we want. Really, really tiny. 0.0000000000000, a million zeros and then a 1. It could be really, really small. When we do that, the distance between these two gets smaller and smaller. So let's say I make h, this big, over to here. Then you get this point up here, and your secant line kind of moves. Starts rotating around the graph. How close to this x can I get? Oh, as close as I want. So I can pick this h. And what eventually happens is we get a line that hits the graph exactly. I'm drawing that poorly. Get a line that hits the graph exactly once, at one point. That turns into something else. That's called, do I have room? Tangent. When it hits the graph only once. If it hits the graph only once, that means instead of an average rate of change, we're talking about what's happening at a specific point. How fast are you going when your car hits a tree?
Zero.
No.
Oh, like how fast were you going?
Let's put it this way. If you're in a car and you're revving the engine and it slips into gear, what's going to determine how much damage is caused when you hit the tree? How fast you're going at the time you hit the tree. Now, your speedometer does not work on instantaneous velocity. It works on average value. It does a little average calculation about a second long, and it won't tell you the exact speed you're going. So the only way to calculate it out is a little bit of this junk to figure out how fast you're going at an instant. So this is kind of a cool idea. And the way it works is, this is the only piece you do not know. You do not know g of x plus h, so guess what you have to go find? G of x plus h. You already know g of x, it'll be given to you, and h is just a number, just a value. This is a formula.
Oh.
That's all it is. It's just a formula, and we're going to evaluate the formula.
So that X will be a number eventually?
Nope,
No.
never. Well, eventually, at the very, very, very end of this whole thing, it might turn into a number. But it's better to leave it as just x, because x can be any number, any possible domain. So, for example, let's say I have f of x is equal to 3x squared minus 5. Nice little baby polynomial. And I want to find the difference quotient. So the first step of finding the difference quotient is to find that missing piece. So I need to evaluate f at x plus h. How do I do that?
Let's see.
Plug it in. How do I plug it in? Take the x and replace it with?
X plus H.
No.
3x.
Parentheses.
Squared minus 5.
Stop that. Replace x with parentheses. So it's 3 times something squared minus 5. What goes inside the parentheses?
So x plus any number?
X plus h. Don't worry about anything. Whatever is over here has to go in there. It has to. So this is x plus h. We've been doing that all along, you know. F of x, g of x, x plus h, g of x plus h. You just plug it in. So what is x plus h all squared? Please do not distribute the 3 through. It's going to be x squared plus xh plus xh
Plus H squared.
plus another xh.
Oh.
There's going to be 2 of them, right?
Yeah.
So it'd be 2hx.
2H.
2hx. You don't see it, write it twice.
Why don't you switch them around?
Alphabetical order.
Plus h.
No, trust me, when you're
No,
multiplying
I-
both
I
variables together,
understand.
alphabetical order. If you left it 2xh, it's not going to hurt anything. Plus
H squared
h squared minus, don't forget that 5.
minus 5.
Alright, then distribute the 3. And you're going to get 3x squared plus 6hx plus 3h squared minus 5. Yay! So this is f of x plus h, this whole ugly, nasty thing. Alright, if I plug it into the difference quotient, it looks something like this. F of x plus h minus f of x all divided by h. So the first piece is going to be that f of x plus h. So in here I have to put f of x plus h. Over here I have to put the original function.
Alright, so that whole, what we just came up with, the 3, that whole thing goes in
Here, it goes in the first parentheses. So you get 3x squared plus 6hx, I don't have enough room, plus 3h squared minus 5. Well, I highly suggest you don't do it exactly the way I'm doing it. I'm just showing you the setup. Give it the first parentheses, put in f of x plus h. Give it the end parentheses, and go minus whatever. Be really careful. You're not watching. Ready?
I'm trying to.
Take f of x plus h and put it in here, but I wouldn't write it out like I have, because you might not have given yourself enough room. So write the f of x plus h, put it in parentheses, and then go minus. Make sure you put the other function. This one's more important to put in parentheses.
So,
minus 5.
oh, f of x is 3x squared minus 5.
3x squared minus 5. And then simplify.
Do what now? 3x squared minus.
And the
That's
whole
the
thing
original
goes
problem.
over h.
The original function, f of x.
Yuck.
So this piece goes here. This piece goes there. Just plugs right in. It's really nice.
I'm still not feeling where. I don't understand where you're getting the f of x from.
It's the original function. I made it up.
Oh,
I have to give
I
that
see
to
it,
you.
I see it.
Okay. Big box around it, everything. Here's the cool thing. What happens with 3x squared?
They go away.
They go away because this one's positive and this one will be negative. What happens to the 5s? They go away. This one's negative 5. This one will eventually be positive 5, so they go away. If you're working with a polynomial, your original function is going to disappear. It's going to cancel out all the pieces of the original polynomial function. Now, the key word there, of course, is polynomial. It does not work on all functions. All right, what's left over becomes part of our answer. So 6hx plus 3h squared, all divided by h. Am I done?
Would you factor that?
I can take out a
H.
h. So, no. All you care about is the h. I care less about the 3. Take out the h.
See,
You teach us one thing,
Oh,
one chapter, and then
but-
Well, if you want to pull out 3h, it's fine. But the important part is
The h.
the h. I could care less about the 3.
But
You only factor if it's going to simplify. Just trust me on this one.
Okay.
If you pull out the
So
h,
we want to reduce, but we don't want to reduce.
well, think of it. There's a 3 in the top, there's a 3 there, but there's no 3 in the bottom. So the 3 is really not going to help you do anything.
Okay.
It's really just the h, and the h is going to be the main
Like-
focus of this whole thing.
So yeah, H.
6x
Plus 3H.
plus 3h, all divided by
H.
h.
So that.
And the beauty here is now the h's
Can.
cancel, and you're just left with 6x plus 3h. Now, if you want to pull out a 3, that's fine. It's not going to hurt you. Now, what's cool about that is, at the beginning, h could not equal 0. The cool thing about the end is h, if you really, really wanted to, h could actually equal 0 here. And then you're just left with 6x. And 6x has a special name, it's called the derivative. But you don't have to worry about that.
So that's what the H is called.
The answer for you is going to be 6x plus 3h.
We're
6x.
not really.
In calculus,
Plugging
the,
it
in calculus, the answer is 6x.
Okay.
But for you, it's 6x plus 3h. Now, polynomials is not the only possibility, but it's the one.
Like that one?
Do another one like that one? Yeah, we could do one real quick. Very fast.
Very fast.
Very fast.
I'm sorry.
Let's say g of x is equal to 4 minus 5x, minus 5x, minus, I did 3 over there, 7x squared. That's horrid enough, isn't it?
Sure.
Okay, and we're going to find the difference quotient. So the first thing you need to find is g of something. So I write down what's called skeleton form. What am I finding? G of what? To use the difference quotient, I only need to find one thing. G of what?
X.
I already have g of x. It's right there. G of x
2
equals...
H minus
What is it?
H.
No.
X plus H.
Oh, x plus h. So I'm going to plug in g of x plus h and find out what it is. So if I put x plus h in this parentheses, you better put them in all of them. You can't change the value. And then simplify or expand. So if we expand, let's see, this becomes g of x plus h is equal to 4 minus 5x minus 5h minus 7 times. Does it change?
No.
No. What is it?
X.
X squared plus 2hx plus h squared. Thank God I don't give you a cube. Cubes get uglier. So g of x plus h is equal to 4 minus 5x minus 5h minus 7x squared minus 14hx minus 7h squared. Remember all those times I was torturing you with polynomials and multiplying them together and expanding? This is the reason why. This one little piece is the major reason why you want to play around with polynomials. All right, this whole thing is g of x plus h. So we're going to plug it into our little formula. So it's g of x plus h, which is 4 minus 5x minus 5h minus 7x squared minus 14hx minus 7h squared. The biggest mistake that people make here is they don't write all of them out because there's a ton of them. So be really careful. At the end, I highly suggest you go 1, 2, 3, 4, 5, 6 terms and make sure your thing down here also has 6 terms. Minus the original function, 4 minus 5x minus 7x squared. Take this whole thing and divide by h. Okay. And then it's a polynomial, so things are going to cancel. The 4 is going to cancel with the 4. The negative 5x is going to cancel with the negative 5x right over here. And the 7x squared is going to cancel with the 7x squared over here. And you can double check yourself if you want. It's negative 7x squared on the left. It'll eventually be a positive 7x squared on the right. Therefore, they additive inverse themselves away. Remember additive inverse? All those fun things. What's left over is negative 5h minus 14hx minus 7h squared, all divided by h. What should we do next?
Take out an H.
Take out an h. So h left behind,
Negative 5.
negative 5,
Minus 14X.
14x
Minus 7H.
minus 7h, all divided by
H.
h. And you get a final answer of
Negative 5 minus 14X minus 7H.
and there's your answer. The difference quotient of this function is equal to negative 5 minus 14x minus 7h.
I think if I could just remember
Where it
big,
is.
long, see, I would be thinking, oh, this is too big to go in.
No, it needs to go in there. But it only gets big with polynomials.
So the big one goes in the first one and the original goes in the
F of g of x plus h.
Just remember
F of x plus h minus f of x divided by h. Now, the functions are not always polynomial. For instance, so here's a rational function, but I still can find the difference quotient. And then actually the beginning of it is easier. Where at the beginning of this, you have to crank out g of x plus h, expand it out. With this one, it's actually very easy. So if you do f of something is equal to 3 times something minus 2, what's the something?
3 over
X plus
H.
h.
Oh, I keep forgetting that.
That's why I keep pausing on that part.
H.
And that's it. I mean, that's f of x plus h. There's not really much you can do to expand it, simplify it, write it different. You're stuck with that. So then you get into the formula, and it's f of x plus h minus f of x, all divided by h. So what goes in my little parentheses? Well, this first ugly piece is 3 over x plus h minus 2. The second piece is 3 over just plain old x minus 2. Don't change signs. And we're stuck. The goal is the same. Over here, the concentration was get the h out of the bottom. Because we eventually want h to be kind of like 0, but not exactly 0, but really close to it. But here, it would cause us a lot of problems, because if you divide by numbers that are closer to 0, your answer goes off to infinity. And I don't want that situation here. So I need to get rid of this h. So that means there has to be some kind of thing I can do to this to get rid of that h. So what kind of fraction is this?
Complex.
Complex. And how do I deal with complex fractions?
GCM. Or not great confederate.
Common denominator. Just go
Yeah,
for common
that
denominator. What is the common denominator here? What do you want to do with it?
Well, x minus
X minus 2
Times
H.
X plus H minus 2.
times x plus h minus 2. You have to use the whole thing. You can't use part of it. Because that long line is a parentheses, remember? You see these long fraction bars and automatically you go, oh, here's one piece, and oh, here's the other. So you have to multiply by both of them. Every single term. So I'm going to distribute it across the top. X minus 2 times x plus h minus 2. And when I distribute it across the bottom, well, that's just hitting one thing. Oops. You just multiply the h by it, because the denominator of h is just 1. So it's not going to do anything there. So the bottom, you're just going to kind of leave it alone. Just leave it. Don't cancel anything, just leave it. The top, though, is kind of cool. When the x minus 2, x plus h minus 2 runs into this first fraction, what happens?
So I don't do it on both sides. So I don't.
Sides?
So this is one piece.
Yeah, it's an expression, not an equation.
So,
But I'm distributing it across the top, so it's going to hit both
minus 3x
pieces.
minus 6.
Right.
Well, the x plus h minus 2's are going to
Cancel
cancel,
out.
and you're left with a 3 times
Minus 6.
x minus 2. Just
Oh,
bear with me.
alright, sorry.
3 times the quantity, x minus 2. You can distribute it if you want, but that's where most mistakes are made.
What?
What? The x plus h minus 2's cancel, and you're left with a factor of x minus 2 times the 3 that's sitting on top.
But why don't the other two cancel?
Okay, we're not there yet. Why? There's a minus sign. We're distributing. So it hits the first one, then it'll turn around and hit the second one. Minus, when the 2 pieces run into the second fraction, what goes away? The x minus 2, and you're left with a factor of 3 times x plus h minus 2. All divided by, well, that whole ugly mess. H, x minus 2, x plus h minus 2. Question. Can anything cancel?
Oh, I see what you're doing, okay.
Yes.
What?
Yeah. Both, all of the things in.
And then I get to yell at you. You can only cancel if everything is multiplication and or division. What's sitting up top? A big old minus sign. Guess what you can't do? I distributed it.
Can't you do it some more?
No. Oh, I can foil or
Oh,
distribute the top out, yeah. But you can't cancel x minus 2 with the x minus 2 in the bottom.
You gotta flip it.
You can't do that either. There's a minus sign here. Don't do a darn thing about canceling.
Distribute.
You can distribute across the top and see what happens, but you can't do anything top to bottom. It doesn't work that way.
And why is that?
Because there's a minus sign. Do I have to go over this ideas again? What's this equal to? Is it 4 plus 3, which is 7?
No.
Actually, in this case, it is. That's not what I wanted to talk about. Darn it. Oh, actually it is, because if I cancel the 2 with the 8 and make it a 4, the answer is not 10.
No.
The answer is 7. So if I cancel the 2 with the 8, I also have to cancel the 2 with the 6 and make it a 3. But if you just cancel x minus 2, you can't cancel with x minus 2 over here, so you can't do it. Okay.
Okay, I got you. No, I follow you.
Okay.
All right.
Distribute out the top and you get 3x minus 6 minus 3x.
Because it's not two, if it's not two separate parts on the denominator.
If you can't do it to all of them, you can't do it to any of
Okay, I
them.
follow you.
Minus 3h.
Minus 3h plus 6. All over h x minus 2.
So now we are
plus
distributing?
h. We're distributing across the top, but we can't do anything top to bottom. The biggest mistake I've ever seen is x minus 2's cancel and all of a sudden things get really weird.
So the
So
six
top
cancels
cancels
out
out
3, negative 3.
Well, the 6's are going to cancel out, which is nice.
The 3 is
The
canceled.
3 x's are going to cancel.
Just negative 3.
Negative 3h.
Let me bring this up here. Negative 3h over
h times
x minus 2,
x minus 2.
x plus
X
h
plus h
minus 2.
minus 2. And the
And then the-
h's.
And the
Cancel
beauty is what
out.
we wanted. The h's are going to cancel. That's the whole goal of this. So our final answer is negative 3 over x minus 2,
Minus 2.
x plus h
X
minus 2.
H minus 2.
Ta-da.
See, I gotta do something different because I keep thinking that x plus h is just a th and it's throwing me off.
A th.
Instead of being plus, I'm thinking
Oh.
this is a T.
Now think of this. When I write a t,
I always put a little swirl or a little.
my t's I always write this
Yeah. So
way. Just so they do not look like.
I need to do
Pluses.
that for my h's, so I.
No, you need to do that for your t's.
Yeah.
and
Start
T.
doing a cursive t. Start doing a cursive t. That's all you need to do. What's that?
It's cool.
That's cool. Don't mind her, she's delusional back there. Alright, the last type. G of x is equal to,
Last type.
Yeah, what
Yeah.
type is that? I mean, what type have we been on?
oh, they're all difference quotients, but the first one was a polynomial.
Oh, okay.
The second one, this one, is a rational function. This one is square root function. So how you treat them actually turns out to be different.
So wait a minute, you said that one is called what?
Rational. Rational. Because it's a fraction. Rational. Definitely not a polynomial.
And the
Because
first one
polynomials
was
can
a-
have variables in the bottom.
The first one was a what?
Polynomial. Well, actually, we did 2 polynomials in a row.
No, the other one's was
When it has squared,
Trinomial is
it's a
still
polynomial,
called
right?
a polynomial.
When it has x plus a squared, that's when it's a polynomial.
Huh?
When it has
Polynomials are anything that has a coefficient times a variable raised to a whole number power. And the sum of those things. It can be as many terms as possible. So the first thing you're going to find here, again, is g of x plus h. Difference quotient. Again, there's not much simplification to go on, because all you're doing is replacing x with x plus h, and there's not much I can do with that expression. What?
What did you say this one was called again?
Radical?
Right.
Radical, probably be the best way to call it. Technically square root, but radical function. So once I plug in x equals x plus h, I can't do much with that. So I put it into the format, which is x plus h, g of x plus h, minus g of x, all divided by h. So writing it out, not that hard. So that means the second part of it must be
X plus H
horrid.
minus square root of X minus 3. Because I need to write this down thoroughly because I
Makes me
know.
worried. Okay, goal is the same. I need to get rid of the h at the bottom, but there's a problem. This h is buried underneath a radical, and there's no way of bringing these two things together. If I could, then the h's would cancel rather nicely, but you can't square this out an equation. So how do I get rid of the radicals, or at least some of them?
You can't do the square root.
You can't square them,
Oh, you cannot.
because it's not an equation, it's an expression. Squaring the top and the bottom is not a way of simplifying a fraction. I mean, if you think about it, if you have 2/3 and you square top and bottom, you get 4/9, which has nothing to do with 2/3. They're not equal expressions. They're not equal. So squaring is not going to help. So what's another little trick with radicals that you know?
Get it by itself.
The what?
Get it by itself.
No. What's a trick with radicals?
There's a lot of them.
No, there's only one that's really important.
I have no idea.
I even gave it a name. It began with a C.
I know what it is.
What is it?
I gotta look for
No,
it.
don't look for it. I want you to do it off your top
I
of your
know
head.
what it is.
C-O-N?
He always know what it is.
What's it?
Conjugate.
Conjugate. Conjugate. What is the conjugate of the square root of x plus h minus 3 minus the square root of x minus 3?
It's minus H plus
X what? No. Conjugate is two terms, and you only change one sign, usually the one that's sitting in between them. The only sign
That's
sitting
right.
in between them is
And then
that one. So the conjugate of it is going to be the square root of x plus h minus 3
Plus.
plus the square root of x minus 3. And we're going to multiply top and bottom, and again, we're not going to mess with the bottom.
Dude, what? I don't have
You multiply by the conjugate. A plus b, a minus b.
Did you just add that to the line?
I multiplied top and bottom by it.
That's what I.
I didn't add it, I multiplied it. I included it, how about that? If you put it in the top, you have to put it in
Right.
the bottom. Alright, if we FOIL out the top, this gets messy, but they're conjugates, which makes it nice. If we multiply the first two together,
Wait, because see, this is why I had to go to a tutor for this point right here.
because you're using an eraser.
Because okay, now I am ready.
Are you sure?
Ready.
No.
We don't talk to her.
All right, continue.
Continue. So, when we multiply the first two radicals together, what happens?
They go poof.
What goes poof?
All the whole thing.
No. What's the square root of 5 times the square root of 5? Does it just go poof and disappear?
No, it's 5.
Oh, it's 5. It's whatever's underneath the radical.
So it's x plus h.
X plus h.
Minus 3.
H
Minus 3.
minus 3.
Okay. Now, when we do the inner and the outer, what happens? You know,
You get
this one times this one, and this one times this one way over here. What happens to those two? They cancel, because one's going to be positive, the other one's going to be negative. It's a property of conjugates. What happens when we multiply the last two together? You get x minus 3. What sign is between these two things? And if there's a minus sign between them, this one better go in parentheses, because it's minus the entire thing.
All right, hold on. Why didn't you do the x plus h minus 3 times the x minus 3?
Because when you multiply this one to this one, you get a positive thing, and when you multiply this one to this one, you get a negative
Oh,
thing.
okay, so they did.
And the positive thing and the
Follow.
negative thing become 0.
All right.
So we don't have to worry about that. All over, and don't you dare do a thing with the bottom. H times the square root of x plus h minus 3 plus the square root of x minus 3. Cool.
Distribute the top. Well,
Now, when you distribute the top, I'm going to simplify it real quickly. You're going to get a negative x, but this one is positive x, so they go bye-bye. This one's going to become a positive 3 after you distribute it. This one is a negative 3, and they go bye-bye. And we're left with
H.
an h in the top,
And
Plain old
everything at
H.
the bottom.
plain old h in the top, oops, all over h times the square root of x plus h minus 3 plus the square root of x minus 3. And the beauty of this is the h is canceled. What are you left with?
Wouldn't it be 1 over?
Yep, 1 over the square root of x plus h minus 3 plus the square root of x minus 3. And there's our answer.
Can we do one more?
So, no, that's all I'm going to do with those two. So the trick is polynomials, expand them out, things cancel rather nicely. Rational functions, you're going to use the complex fraction trick of multiplying everybody by their common denominator. When it's radical, you have to think conjugate. Radicals, usually you have to think conjugate. It's the only trick that really simplifies them nicely.